Hello, and welcome to this Richardson RFPD and Microchip webinar. Now I would like to introduce today's presenter. With us today is Pradeep Kulkarni. Pradeep is a product marketing manager of the Silicon Carbide business unit at Microchip. And now I'm going to pass things along to Dave Ross from Richardson RFPD to kick things off today. So Dave, go right ahead.
Thanks, Katie. And thank you everyone for joining today's presentation featuring Microchip, mSiC plug-and-play gate driver family. It's available with full design support from Richardson RFPD. Richardson RFPD, an aero electronics company, is a specialty electronic component distributor focused on RF and wireless communications, industrial IoT, power conversion, and energy storage markets. With our global reach and extensive technical capability, including a specialized focus on GaN and SiC technologies, Richardson RFPD serves its customers through component development and selection, technical support, and world-class logistics and supply chain capabilities. In these co-sponsored webinars, we strive to provide a topic to the power electronics engineering community that addresses a design challenge and provides information on innovative technologies to help our customers and prospective customers differentiate their own products. Today is another example. Complementing its broad portfolio of silicon carbide diodes, MOSFETs, and modules is Microchip's gate drive solutions to help boost the efficiency and performance of silicon carbide power modules manufactured by Microchip as well as other leading silicon carbide manufacturers. So let me now turn it over to Pradeep Kulkarni to detail how Microchip's gate drive solutions are further helping companies adopt silicon carbide with ease, speed, and confidence. Over to you, Pradeep.
Hello everyone, I am Pradeep Kulkarni from Microchip. I lead the product marketing activities for Microchip Silicon Carbide gate drivers. I do see participants joining from all parts of the world. So for some of you, it's early morning, and for some of you, it's late night. So I appreciate you taking out the time to join today, and I welcome you all for this webinar. Today's topic is plug-and-play gate drivers, and here is the agenda for today that I'm going to cover. So when I talk about plug and play, this means different for different people. So what I am going to do is I'll go through a flow where we talk about why a plug and play gate driver is needed. Then we will go through when to use it, how to use it, and what are the applications that benefit most of the plug and play gate driver. And finally, what would be the Microchip offerings for this plug and play gate drivers? So I will try to keep this presentation for about 30 to 35 minutes so that we have enough time for Q&A at the end. So I would encourage people to have more interaction. At any point, if there is any question, don't hold back, put them in the Q&A window, and we will definitely address them at the end. With this, let's get started. So I want to take this opportunity to talk a little bit about Microchip technology. So for those who are new to Microchip, will find this information very useful. For you who are already knowing about Microchip, this is just like an latest update. So Microchip is a US-based semiconductor manufacturer with headquarters in Chandler, Arizona. And FY23, financial year 23, we closed around $8.4 billion in terms of revenue. Microchip, as you might know, is very popularly known for its microcontroller. But that's not all, right? So today it carries a wide portfolio of digital, analog, mixed signal, power, and interface products. which serves as a total system solution to our clients in solving some of their key design challenges. About microchip silicon carbide. So silicon carbide is a very key focus area for microchip, and we are not new in silicon carbide. So if you see here, Microchip has been involved with silicon carbide for over 2 decades now, uh, and has been shipping right from 2003. So this establishes the heritage and the credibility for Microchip in silicon carbide. And if you see the latest in 2022, we had our 3.3 kV SiC device family, and Microchip was one of the few to have achieved this high voltage of 3.3 kV. So this is about our product portfolio. So I would introduce you to this mSiC portfolio. Microchip offers a complete portfolio right from dies, discretes, modules, and gate drivers. So in dies and discretes, we offer both MOSFETs and diodes, starting from 700 up to 3.3 kV voltage class at various RDS on and current levels. In module packages, we again offer both MOSFET and diode modules. So these modules comes with a higher current capability, and we offer a lot of standard module packages. So in our standard module packages, one of our key product is SP6Li, which offers industry's lowest tray inductance. It's a lowest tray inductance package. It offers 2.9 nanohenry, and the way it benefits is it's very helpful in high frequency operation. Because there are less oscillations within the package at this high frequency operation. One of our key strength is also so in modules again one of our key strength is also custom power modules, and we have a great legacy into developing custom power modules. We have done it enough for aerospace and defense applications. We have done it for some of the industrial applications. So we have got a strength to play in custom power modules. So the last but not the least, we offer gate drivers, and these gate drivers come in various form factor. One of them is plug and play gate driver, which is the topic for today. We are going to talk about. And when I talk about plug and play gate drivers, these gate drivers are typically meant to be used with power modules, and this generally are used for medium to high power applications. The next slide, before I go deep into plug and play gate driver, I wanted to give you an overview of why a silicon carbide needs a gate driver, right? So as most of you are aware, every switch needs a driver, and this holds even more true when it comes to silicon carbide world. So while silicon carbide comes with a lot of benefits, and some of the benefits like faster switching, higher efficiency, higher temperature operations, uh, these are some of the benefits that silicon carbide offers. But what happens is at the same time, due to the faster switching, it creates a lot of secondary effects, and these secondary effects are something like voltage overshoot. We have EMI in the circuit. Then we have some short circuit that appears. So these secondary effects are very well addressed by using a gate driver. So that's where the importance of gate driver in silicon carbide. I wanted to highlight comparison of going with discrete versus plug and play approach. Both these approaches have its own benefits. But in order to choose which one is the best, we would need to put some context around it and then compare the benefits. So when you look at the gate driver for medium to high power applications where SiC modules are used, there using a plug and play driver adds a lot of advantage. One of the key benefit is definitely time to market. So when you are faster to the market, you achieve two benefits. One is you start to revenue earlier on your existing product, and the second benefit is that you start your new development much faster. So you could achieve two revenue stream from being faster to market. The other benefit is on the ease of supply chain, and we all know how important supply chain has become these days. While there are some other benefits, but these are the two key benefits I would like to highlight here. Now let's talk about applications. As I mentioned, plug and play is very suitable and for the high power and medium power applications. So let's look at it from the application point of view. So if you see here, some of the applications like railways and within railways or locomotives, we have traction power unit or we have auxiliary power unit where the systems are very complex. It's high power, so there typically the plug and play works better in terms of solving the key design challenges, and also the applications like solid state transformers or DC transmission is where we have seen a lot of proliferation of these plug and play gate drivers. And also there are other applications which on case to case basis fits for using plug and play like industrial UPS. We also have seen a lot of heavy duty e-mobility vehicles want to accelerate their development time, and there is a lot of usage of plug and play gate drivers there. And also the renewables like solar and wind benefit a lot from having the plug and play gate drivers. Till now, I talked about things around plug and play gate drivers, but on this slide, you could see how it actually looks like. On the left side of the screen, there is a visual representation. So basically, it's a driver card which has got gate drive control, which has isolation and gate drive power supply on it, and everything fits to the size of a module and sits right on top of the module. So with Microchip plug and play approach, one of the key benefit we offer is it comes with pre-configured settings optimized for our own Microchip modules. So it's very minimal work when you are designing the complex systems. Another benefit we offer is it's adaptable to other manufacturers' module as well. And this is possible because our VGS is configurable. So we could set up the new parameters easily. Just to give you an example, right? So let's think about a scenario. If tomorrow there is a design spin-off and there is a minor modification needed, then there is no need to redesign or make any hardware changes for the gate driver. You just need to reconfigure the parameter, and that's how our mSiC plug and play gate driver works right out of the box. How part of our plug and play gate driver? One of the key enabler for our gate driver is our own patented technology called augmented switching. Some of the key benefits of augmented switching are we can precisely control the turn on and turn off of the switch, which thereby reduces or lowers the voltage overshoot, lowering the switching losses. And one of the other key benefit is it provides the faster response during any short circuit happening. This slide shows the graphical representation of augmented switching. So the top snapshot shows the graphical editor from the configuration tool that we use internally, and the bottom graphic shows the resultant scope shot. So this example which we have considered is for 600 volt VDS, 400 ampere IDS, and with 1.1 ohm gate resistor. So the first example, the leftmost side of the screen, here if you see the augmented switching is disabled. You see how dropping from 20 volt to -5 volt creates a higher voltage overshoot, thereby resulting into higher energy loss. In the second example, the middle one, with augmented switching enabled and controlling the turn off in step. So here we hold dropping from 20 volt at 0 volt for 50 nanosecond before we further drop it to -5 volt. And this reduces the voltage overshoot to 744 volt, and this reduces the E of loss to 9.9 millijoule compared to 11.1 in the previous example, in the previous scenario. So now for the third example, you could see again starting at 20 volt, then dropping to 4.5 volt, holding it for 650 nanosecond before dropping it further to -5 volt. So you could see here we have a reduced voltage overshoot peak of 712 volt and a lower voltage and current ringing. But what happens is we are the turn off energy is higher here, 16 millijoules, but we are trading this turn off energy for reduced over voltage and ringing. So that's where you see a higher turn off energy. But yeah, nothing comes for free. So if we are trying to reduce the voltage overshoot and EMI, that should get traded with slightly higher energy loss. Introducing our new XIFM 3.3 kV plug and play mSiC gate driver family. And this is the first time I'm talking about it publicly. This is a new product we have, and currently this is in sampling stage. So we plan to release this to production sometimes in October, which is next quarter. You could see the image on the right hand side, and these days we could see many applications, especially in railways, in smart grid, are taking benefits of moving to higher voltages, like 3.3 kV. So definitely those applications can benefit from using our product. Second level details to our XIFM family. Some of the key features we offer are 10.2 kV isolation, which is key to some of the railway applications, and we also offer fiber optic interface, which makes data transfer more secured and faster. Also to highlight, our gate driver comply to railway standard, which is EN 50155. You can also reach out to Microchip for more details. We will be very keen to work with you on this. Just to highlight, we also provide adaptation support to other manufacturer 3.3 kV modules. So that's something, if you can reach out to us, we could together work on that aspect as well. While we spoke about a wide range of topics, here are some of the key takeaways I would like to summarize from today's session. Number one, Microchip offers a comprehensive portfolio of mSiC products and solutions. And you did see that Microchip is not new. We have been in existence from over 2 decades now. Our plug and play mSiC gate driver for power modules, these are well suited for medium to high power applications. And we do support adaptation and customization requests on case-to-case basis. And then we looked at the 3.3 kV family, our new plug-and-play family of 3.3 kV, and also looked at some of its key benefits. I would say please tune into our website. We would be releasing it in next quarter. So please tune into our website for updates, or do reach out to Microchip if you are looking for some kind of details. With this, I would leave you with the resources section. So you could go to our website www.microchip.com/SIC to land on our silicon carbide portfolio, or to directly go to our gate drivers. You could directly go to /mSiC gate drivers, which would directly take you to the gate driver. So thank you very much for being patient with me, and I hope today's session was useful. And with this, I open it up for Q&A. Look forward to having more interactions. Thank you.
All right. Thank you so much, Pradeep. So Pradeep, I'm going to pick one to start with here. This person is asking, do your plug-and-play drivers only support Microchip SiC modules?
Okay, so that's a good question. I assume that he wants to, whoever has asked this question would like to know the different modules come with the different VGS voltages, the gate voltages. So I think that's the primary motivator, I think, behind this question. So I would say that our plug-and-play gate drivers are optimized to a module package, but that's the good thing about Microchip gate driver, plug-and-play gate driver, is that we could optimize for any SiC modules regardless of the VGS voltages. As I mentioned in my presentation, that we offer the configurability, so that would help to adjust the gate voltages to any manufacturer module if it has the same module packages.
All right, Pradeep, thank you so much for that answer. All right, looking in our queue here, this next one is asking, can the drivers be customized?
Yes, I would say it can be customized. So we do offer both. We offer adaptation, meaning if somebody has if a customer has a module and then he wants us to adapt our gate driver to that module, so we could do that. And we also offer customization on case-to-case basis. But that's again understanding the application, what is the extent of customization we would like to work on, and what's the timeline is available, right? So based on that, we definitely work on customization as well.
All right, thank you so much for that answer. For all of our attendees out there, if you have a question today, go ahead and use that Q&A window. All right, Pradeep, our next one here. Can they be used with IGBTs as well as SiC?
Yeah, I would say so. Basically, the gate driver, the plug-and-play gate driver that we have are optimized to drive silicon carbide devices, right? But can also be used for IGBT because as the technology doesn't change and is the gate driver as a technology is applicable for both silicon carbide and silicon IGBTs. So I think we can it can be used for both, but as a standard product, what we offer is definitely optimized for silicon carbide. So we need to do, as I mentioned, adaptation to make it work for IGBTs.
All right, great. Thank you so much for that answer. Just a reminder to our attendees, I did load that PDF in the resource widget. If you click on that widget and you don't see the PDF in there, just go ahead and give your browser a little refresh and it will show up in that window. All right, Pradeep, our next one here. Does augmented switching impact switching time? And then in parentheses, it just has rise, fall, delay.
Yes, it's a good question, I would say. So the technology, right? Augmented switching, you can think of it mimics like a gate resistor. So without augmented switching, you happen to use a gate resistor. So it mimics the same like a gate resistor. So I would say the delay time will not be any different. But however, the rise and fall time should improve, because what happens is as the gate resistor used here is typically smaller than the like non-augmented switching driver. So the rise and fall time should definitely improve with augmented switching.
All right. Thank you so much, Pradeep. We have time for a couple more here. So next one, what topologies or module configurations can the PMP drivers be used with?
That's again a great question. So the current portfolio that we offer is targeted towards half bridge configuration. But yes, we are working on other configurations as well. So as and when we come up with the new configurations, we would definitely have them announced on our website. But also, if there is a need for some configuration, please do reach out to us. We would like to evaluate and talk to you, understand, and if possible, again, we can take it as a customization.
All right. Thank you so much for that answer. So we have one more question left in our queue here. So if any audience members have any last minute questions, I will give you a minute or two to type those in at this time. We can take a couple more questions if anybody else does have one. Pradeep, if we don't get any more in our queue right now, this is going to be our last question for today. But again, we will give the audience members another minute or two to ask any last minute questions. So Pradeep, this last one that we have is, can the 3.3 kV gate drivers support XHP2 or LV100 packages?
Yeah, so again, we have a question on 3.3 kV. I'm happy to answer this. So I would say that the 3.3 gate driver that I just showed in the presentation, so that's, as I mentioned, it's specific to a module package. So the gate driver that we have today is tuned to work with HV Linpack version, right? But we are working on the LV100 package also. So it needs a bit of customization. So we are working on LV100 package for that. So if you have any, so whoever has asked this question, if you have any interest for LV100 gate driver, please reach out to us. We would definitely be happy to talk to you. But I would say that we are considering LV100 packages, and it's something we are working at. But the one that we have today is more towards the HV Linpack version of the module.
All right, Pradeep, thank you so much for that last answer. So as of right now, we don't have any new questions in our queue. So we are going to start to wrap the webinar up right now. So Pradeep, I want to say a huge thank you to you for a great presentation and for answering a few of our attendees' questions. So Pradeep, thank you so much for being here.
My pleasure. Thank you, Katie, for having me.
All right. And for our audience members, thank you all for being part of this webinar event today. Take care, and we will speak with all of you soon.